This is lessons 4.2 and 4.3, ways to prove triangles congruent. So these are shortcut ways that you can use only for triangles. From the last lesson, remember that two triangles are congruent if and only if there is a correspondence between the vertices such that all corresponding angles and all corresponding sides are congruent. That means you're checking 6 pieces of information. 3 pairs of sides that have to be congruent and 3 pairs of angles that have to be congruent. And then secondly, recall the third angles theorem. The third angles theorem says that if you have 2 triangles and there are 2 pairs of congruent angles between the 2 triangles, so there's one pair that's congruent and here's a second pair of angles that are congruent, then you can conclude that the third pair of angles must be congruent. Now, that does not make the triangles congruent. Okay, what it does make them is similar. Remember that similar means they're the same shape, but they're possibly different sizes. Okay, so you could keep the angle measures the same in one of the triangles and blow it up or shrink it down to make it a different size than the first triangle, where they would still be similar, would still have the same angle measures. However, the side lengths would just be proportional. Okay, shortcuts. So here's the first one. The first one is called side, side, side congruence. Okay, I don't want you to call it side, side, side postulate. I want you to write side, side, side congruence. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. Okay, so you're checking one pair of sides are congruent, the second pair of sides are congruent, and the third pair of sides are congruent. In that case, the triangles would be congruent by side, side, side congruence. Okay, the second shortcut, side, angle, side congruence. Now, side, angle, side, the order matters in the way you write the letters. So it's side, angle, side, meaning that 2 sides and the included angle, the one that's formed by the 2 sides, have to be pairwise congruent. So you have a pair of congruent sides and the second pair of congruent sides, but the angle that you know is the one that's between the 2 sides that you know. Okay, so it goes side, angle, side. Side, angle, side. Okay, that's included angle. 2 sides and the included angle. The order here is important. The A is in the middle because it's 2 sides and the included angle. All right, the third shortcut is angle, side, angle congruence. And this one is going to use 2 pairs of angles and 1 pair of sides. And again, the location of the side matters. So you're going to have 2 pairs of angles known to be congruent. Okay, and then the pair of sides that are congruent are the ones that are joining the 2 angles that you know are congruent. Okay, this is angle, side, angle. And again, the order matters, right? Because the side has to be the one that's between the 2 pairs of angles. It's included between the 2 pairs of angles. So angle, side, angle. Angle, side, angle. Okay, and you can't skip over any angles to get to a side. You have to go angle, the next side you come to, and the next angle that you come to. All right, and then the next general one is called angle, angle, side. Now for angle, angle, side, it's still going to be 2 pairs of angles and 1 pair of sides, right? 2 A's and 1 S. However, this time it's 2 pairs of angles, and then it's 1 side that's not the included side. So the included side is the one that's between the 2 pairs of angles that you know. So for angle, angle, side, we're going to pick 2 pairs of angles and then a non-included side. Okay, that means angle, angle, and then not the one that's included, but one of the other ones. Okay, they need to be the corresponding other sides. So it could be that pair of sides, or it could be angle, angle, and then side. Okay, but you don't want to choose A, B, and D, E because that would make it angle, side, angle instead. Now, again, the order matters. Let's go back up here for a second. When you have two sides and one angle, the angle has to be the one that's included between the two pairs of sides. Okay, it has to be included. So you can remember that because angle, side, side is not a way to prove triangles congruent, and the backwards form of that is also not. Okay, so we're not going to be using SSA or ASS. If there's two S's and an A, it's SAS. Okay, so those four are side, 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 angle, side, angle, and angle, angle, side. We're going to do some examples down here, so I'm going to go ahead and write those shortcuts. So we've got side, side, side congruence. We have side, angle, side congruence. Angle, side, angle congruence. And angle, angle, side congruence. I set up above that there is no angle, side, side, or side, side, angle congruence postulate. So that means if you have two pairs of sides and one pair of congruent angles between the triangles, the only way that that's going to make the triangles congruent is if the angles are the included angles. Okay, the included angles. So side, angle, side means you have two pairs of sides and then the included angle measures. Now, why does angle, side, side not exist as a congruence postulate? So here's a demonstration for why side-side angle or angle side-side does not work. So the first thing that you should notice is that there is a triangle here, triangle ABC, okay, that's been created with two pairs of sides and an angle that is not an included angle. Okay, so this would be side, side, angle. And then there's another triangle, that's triangle ABD, that's formed with the same lengths. Here's the first pair of congruent sides. Here's the second pair of congruent sides, and then a non-included angle. Okay, and you can see that those two triangles are not congruent. So angle, side, side doesn't work simply because it doesn't always guarantee that you'll have congruent triangles. When you build a triangle from angle, side, side, it may be that you get an obtuse triangle like this, a triangle ABC, or you might get the other triangle here, triangle ABD. So there's two different possibilities, and that's why angle, side, side, or side, side, angle, whichever way you think of it, does not work as a congruence postulate. The only exception to angle, side, side is when you have right triangles. We don't call it angle, side, side. We call it something else. Okay, if you have two right triangles, so we have two right triangles, and we know one pair of congruent legs, and then the hypotenuse lengths are congruent. That makes the triangles congruent. But we don't call this angle, side, side. We call it hypotenuse leg. Hypotenuse is the side across from the right angle, and then one pair of corresponding legs. So hypotenuse and then a pair of legs. Okay, now again, it has to be a right triangle for that to be the case. And again, you don't call it angle, side, side. You call it HL. If the leg and hypotenuse of one right triangle is congruent to the leg and hypotenuse of another right triangle, then the triangles are congruent by HL congruence. Okay, so that's one more way that we have to prove triangles congruent. I'm going to go ahead and add that to our list down here. After you do this a little bit, you won't have to have the list in front of you necessarily, but at the beginning it's helpful to kind of see what your options are. Okay, so this one again is only for right triangles. It doesn't mean that if you have right triangles that the only way that they'll be congruent is by HL, because you could have right triangles that are congruent by like side angle side, for example. However, if you're going to use HL, it's only applicable to right triangles. Okay, let's do a few quick proofs here. The proofs for congruent triangles are a lot simpler than some of the proofs that we've done. So I think the amount of practice that you've done on proofs and also how visual the proofs are in triangles with congruent triangles will make it simpler. Let's try a few proofs of proving. We're going to do a few examples of proving triangles congruent. Now, the fact that you've done a lot of practice with proofs, and also the fact that these proofs tend to be pretty visual and also use a lot of the same kind of reasons, makes them a little easier than possibly some of the proofs that we've done before. So on this problem, you're given that M is the midpoint of segment HS and segment GT. Okay, that's given information. It is very important that when you write down a step in the congruent triangles proofs, that you mark what that's going to tell you. Okay, M is the midpoint of segment HS, means that those two segments are congruent, and then GM and TM are congruent. So that is simply the meaning of midpoint, right? That's definition of a midpoint. Then it says angle GMH is congruent to triangle TMS. Now notice that we were proving triangle GMH is congruent to triangle TMS. So we know that angle G is supposed to match with angle T. That's why they named it GMS this way. That's why they named it GMH this way, but then they started with T for the other one, TMS, okay, because they're making G and T match up, and the order is important when you're naming angles and when you're naming segments in congruent triangles. Okay, so it said angle GMH is congruent to angle TMS. So the reason for that is that vertical angles are congruent. Yeah, we have enough to say the triangles are congruent, right? That is side, angle, side. Two pairs of sides and the included angles makes the triangles congruent. Now, suppose that instead of stopping with the triangles being congruent, suppose that I had made the proof that I wanted you to determine that segment GH is congruent to segment TS. Okay, GH over here and TS over here. So in that case, after you prove the triangle's congruent, you'd have one more step, and the reason would be, well, because the triangles are congruent, the parts are congruent, right? The corresponding parts. That is definition of congruent triangles. It's what it means for the triangles to be congruent. Okay, the second proof. Use the figure to complete the proof. It says H is the midpoint of segment GJ, and then GI and JI are congruent. Sometimes things will be marked on the diagram, a lot of times they are not. with congruent triangles, it's very important that you mark the pieces that you're using to make it obvious how you're determining your answer. So our givens are step number 1. H is the midpoint of segment GJ. And then statement number 4 is actually given. So don't forget that both givens have to show up there someplace. And if they're not at the beginning together, then they're spread out and you got to find them. Okay, so GH is congruent to JH. That again would be definition of a midpoint because we know that H is the midpoint of segment GJ. HI is congruent to HI. What's the reason for that? Well, it's a shared segment between the two triangles, but I know that you know that if I wrote segment HI is congruent to segment HI, you would know that that is reflexive, right? That is the reflexive property of congruence. So if you've been wondering when in the world we would be using something like reflexive, this is how it's helpful. And this happens fairly often with these problems. Whenever there's a shared segment between two triangles, then you can use that shared segment in both triangles, and the reason is reflexive. Okay, so the triangles are congruent. What's the reason? Well, we have all the side lengths marked. We don't need to use any angles. So the reason for that one is side, side, side. Congruence. Okay, we're going to do a few examples down here just to make sure that things kind of are making sense. So I'm going to walk you through 5 of these problems. Are the triangles congruent? Mark the parts of the triangles that are congruent. State the postulate or theorem that applies. I want you to get in the habit of doing that, especially at the beginning here. Okay, so we were told that segment RS and segment TS are congruent. They've marked on the picture. Sometimes they will, sometimes they won't. Okay, V is the midpoint of segment RT. V is the midpoint. That means that those two parts are congruent, and your reason would be definition of midpoint. Okay, what else can we mark that's not given? Well, reflexive is going to give us segment VS is congruent to segment VS. So that is reflexive property of congruence. Do we have enough to say the triangles are congruent? Well, remember, here's our options. That is side, side, side. The next one we're going to do is directly below it. And as you can see, they have given you 2 pairs of congruent angles already in the 2 triangles. And then again, we have this reflexive segment here. So do we have enough to prove the triangle's congruent? Yes, it's going to be angle, angle, side. Okay, angle. Then the next angle you come to is the one at T, and then your side. So 2 angles in a non-included side. That means it's angle, angle, side, congruence. Let's move to the right and look at this one. My C and Z got a little bit cut off there, so let me fix that. So that's triangle ABC, that's triangle XYZ. So these triangles, you have 2 pairs of sides given to be congruent. But then notice, even though this one appears as though you'll be using side angle side, the angle's the wrong spot in that one. right? So this is the included angle. That's the non-included angle. So that means you do not have corresponding parts in the right positions. And even if you had this corresponding angle down here, that'd be angle side side, right? Not allowed to use angle side side. These are not congruent because the angles are in their own non-corresponding places. Okay, next example. The first column, second row. Okay, so on this one, notice that you have parallel lines this time. Parallel lines are given so that you can get angle measures. Okay, that is a helpful hint that is applicable in all of these congruent triangle problems. The purpose of parallel lines is to give you congruent angles. The purpose of parallel lines is to give congruent pairs of angles. Parallel lines are not congruent in general. Okay, the purpose of them giving you parallel lines is so that you can find some angles, whether they be corresponding or alternate interior or whatever kind of angles they are. Okay, the purpose is to give you congruent angles. Now, we were given that the parallel segments are congruent. That does not have to be the case. However, on this problem, that was given. We also have our reflexive segment there. Okay, and then notice that the parallel lines, if you consider that to be your transversal, that's going to give you this angle and that angle congruent, because if parallel lines are cut by a transversal, then what kind of angles are those? They're alternate interior. So guess what? You can't just forget everything that you knew in the last chapter, that the parallel lines will keep coming up throughout the year. Here, then also when we talk about quadrilaterals later on. Okay, so why are the triangles congruent? We have two pairs of sides, and then where is the angle? The angle is included between the two sides. Okay, so you have the sides, and the angle is made up by those two sides. So this would be side, angle, side, congruence. And then lastly, we're going to jump down to the middle of the bottom row. Okay, and I want you to notice on this one, these are right angles. And so we can use those as congruent angles because all right angles are congruent. That is a theorem. All right angles are congruent. So there's our pair of congruent angles. Then we were given the pair of congruent sides, and then we also know that the shared segment there is the same by reflexive. Reflexive property of congruence. Okay, why are those triangles congruent, or are they not congruent? So it kind of looks like it might be angle side side, but oh, wait a minute, angle side side's not a thing. Okay, so remembering that they're right triangles, we're going to check hypotenuse leg. So do we know the two hypotenuses? Yes. Do we know a pair of legs in both triangles? Yes. So this is going to be hypotenuse leg. Okay, HL only works for right triangles. H stands for hypotenuse, L stands for leg. So HL, not angle side side. Again, that does not exist. Angle side side is not a thing. Does not exist. Boom. No. Okay, you do not have to finish the rest of these problems. You are going to be given problems on the homework that are similar to these but might be a little bit simpler. So we will resume going through these problems on this page the next time I see you in class. Thanks.